In 1998, Nestle quietly began buying water rights beneath rural America. Not rivers, not lakes, not surface reservoirs people could actually see. They targeted something far more valuable: ancient underground aquifers buried deep beneath Americans' farmland. Aquifers formed through thousands of years of geological filtration, hidden beneath layers of limestone and rock, producing some of the purest groundwater on Earth. By 2022, Nestlé and its successor companies had secured extraction permits across 34 American states, pulling an estimated 1.8 billion gallons of groundwater every single year. The shocking part was never the amount. The shocking part was the cost. In many counties, these corporations paid less than $200 annually per extraction site to remove millions of gallons of water from beneath American soil. Then they bottled it, covered the labels with mountains and forests, and sold it back to the public for $1 to $2 per liter, often to the exact same communities sitting directly above the aquifers being drained. This is not internet speculation. This is not a conspiracy theory. Every permit exists inside public government archives. Every extraction volume, every permit, renewal, every approval filing can be found inside state departments of natural resources. The information was always there. Nobody simply told the public where to look. But hidden inside those same archives was another discovery. Almost nobody noticed. 11 Old Order Amish families living near Shreve Township in Wayne County, Ohio, had no groundwater extraction permits at all. No municipal water connections, no bottled water purchases, no water bills going back generations. Since 1931, these families had been collecting their complete household drinking water supply directly from the atmosphere itself. Every night, while corporations drilled deeper into aquifers beneath rural America, these families quietly harvested clean drinking water from the air using salvaged metal panels, gravity, stone storage systems, and a surface coating that cost less than a cup of coffee to make. A family of 7 collected nearly 40 gallons of drinking water per day, without pumps, without electricity, without refrigeration, and without touching the aquifer beneath their land. For more than 92 years, the system continued operating almost invisibly. Nestle knew Wayne County existed. Their hydrogeological survey teams had been mapping the region's groundwater resources since 2009, the exact same year their North American Extraction Division filed permit applications targeting nearby aquifers. 4 years later, in 2013, a water resources researcher named Dr. Mitchell Carver arrived in Shreve Township carrying professional measurement instruments and complete skepticism. Carver held a doctoral degree in hydrology from Ohio State University. He had spent over a decade studying rural water systems throughout the Midwest. According to everything he understood about atmospheric moisture and continental climate systems, what these Amish families claimed should not have worked. Then he measured it. The discovery started with a strange phrase repeatedly appearing in county survey documents. Carver's field assistant noticed that across 11 Amish properties, the listed primary water source did not match any recognized category. It was not a well, not a spring, not municipal water, not a creek. The same 2-word answer appeared over and over again. Air collection. At first, they assumed it was a misunderstanding or translation issue. It wasn't. Carver drove to Shreve Township the following week, expecting to disprove the claim immediately. Instead, he found a system mounted on the north-facing wall of a large barn. Angled galvanized steel panels connected to clay drainage. Pipes directed collected water downward into a covered stone cistern buried beside the farmhouse foundation. The farmer calmly explained that his grandfather built the system in 1931 and that it had supplied the family's complete drinking water needs ever since. Carver measured every detail personally: the panel dimensions, the mounting angle, the overnight condensation yield, the drainage rates, the storage temperatures. He sat staring at his notebook for a long time before writing down the numbers, because, according to his training, they should not have been possible. Yet, there it was, a system constructed using roughly $6 worth of purchased materials in 1931, consistently producing around 40 gallons of water per day for a 7-person household during summer conditions in Ohio. What Carver discovered was not magic. It was a forgotten form of atmospheric water harvesting called passive radiative dew collection. The science behind it had existed for centuries. Ancient Middle Eastern civilizations once used stone surfaces to harvest dew overnight in arid climates, but the Wayne County installations represented an unusually refined and efficient version of the technology. The principle was brutally simple. During clear nights, certain surfaces lose heat to the night sky through infrared radiation faster than surrounding air can warm them. As the surface temperature drops below the dew point, atmospheric water vapor condenses into liquid water. Gravity then carries the condensed water into storage containers. No electricity, no compressors, no pumps, no refrigeration systems, just temperature differentials, physics, and careful design. The key breakthrough involved the surface coating applied to the galvanized steel panels. According to a forgotten 1947 USDA Agricultural Engineering Bulletin, Amish communities in Wayne County used a mixture of raw linseed oil and finely powdered hardwood charcoal spread across the metal surface. The coating dramatically increased water collection efficiency. Bare galvanized steel radiates heat poorly. It only emits around 25% of the infrared energy theoretically possible. But the charcoal linseed coating raised emissivity levels to approximately 92%, allowing the panels to cool far more efficiently during nighttime conditions. Lower surface temperatures meant higher condensation rates. More condensation meant more drinking water harvested from the atmosphere. The coating also changed how water behaved on the surface itself. Instead of forming individual droplets that trapped heat and reduced efficiency, condensed moisture spread into thin, continuous films across the coated panels. This allowed the surface to remain colder for longer periods, sustaining high collection rates throughout the night. During Carver's overnight field measurements, coated panels produced approximately 31% more water than uncoated replacement panels mounted beside them under identical weather conditions. The geometry mattered too. The panels were mounted precisely 20 degrees from horizontal. This angle balanced two critical functions simultaneously. It maximized exposure to the night sky for radiative cooling while allowing condensed water to drain downward efficiently into clay collection pipes. Even the spacing between panels turned out to be essential. Most documented installations from the 1947 USDA survey used edge-to-edge panel placement with zero spacing between adjacent sheets, but the Shreve installation used consistent 2-inch gaps across the entire 7-panel array. At first glance, the spacing looked insignificant. It wasn't. During winter nights in Wayne County, panel surfaces often dropped below freezing temperatures, between 2 a.m. and 5 a.m. Thin films of condensed water froze directly onto the panels. As sunrise rapidly warmed the metal each morning, thermal expansion occurred. In zero-gap systems, adjacent panels pressed against each other during expansion, creating microscopic buckling forces that slowly cracked the coating over thousands of freeze-thaw cycles. The 2-inch spacing prevented that stress transfer entirely. Each panel expanded independently without compressing neighboring panels. The result was extraordinary durability. While most conventional coated systems degraded after roughly 8 years, the original Shreve installation continued functioning after more than 12,600 cumulative freeze-thaw cycles across 92 years, still operating within approximately 6% of its original measured efficiency. The water storage system itself required no chemicals, no filtration cartridges, and no chlorination. The underground fieldstone cistern maintained complete darkness and naturally stable temperatures below 60 degrees through thermal mass and burial depth alone. The environment prevented algae growth and bacterial contamination without relying on industrial treatment systems. Then came the disturbing realization. The entire system existed outside modern water regulation frameworks. The Amish families held no registered water rights because they extracted nothing from the ground. Since they did not pump aquifer water, they had no legal standing during groundwater extraction permit hearings. They received no notification when nearby aquifers faced commercial withdrawal proposals, because legally their water systems did not exist within the regulatory structure governing water extraction. In 2015, a Nestle permit targeting the Wayne County aquifer system was ultimately withdrawn, but not because of the Amish atmospheric collection systems. The objection came from concerns involving downstream municipal water intakes near Millersburg, Ohio. Municipal utilities had lawyers. They had institutional representation. They had recognized legal standing. The Amish families had none of those things because the law only recognized people extracting groundwater, not people harvesting water from the atmosphere. That made the entire system effectively invisible to municipal billing systems, invisible to groundwater extraction databases, invisible to commercial water markets, invisible to the bottled water industry itself. A family producing its own drinking water from atmospheric moisture could not be metered, commodified, or charged monthly access fees. Their water never passed through corporate infrastructure. It never entered a utility pipe. It never generated extraction permits or consumption records. For over 9 decades, these systems operated quietly inside a blind spot, so complete that major hydrogeological survey teams mapping Wayne County's water resources apparently ignored them entirely. Even a doctoral hydrologist initially arrived expecting failure because modern institutional knowledge had largely forgotten such systems could function at all. The full installation process remained shockingly simple. Salvaged, corrugated, galvanized. Steel cut into 24-48-inch sections. A charcoal and linseed oil coating cured outdoors for approximately 2 weeks. Mounting brackets positioned at 22 degrees with 2-inch spacing between panels. Clay drainage piping directing condensate into a 500-gallon underground stone cistern sealed beneath a fitted stone cap. Purchased material costs ranged between $4 and $8 for fittings and hardware. Most metal came from salvaged barn roofing. The charcoal often originated from farm heating ash. Meanwhile, Nestle continued filing additional extraction permit applications in Ohio counties surrounding Wayne County between 2016 and 2021. None of those applications referenced atmospheric collection infrastructure. None were required to. The permit review process contains no mechanism for accounting for water systems that do not extract from aquifers directly. Today, the 11 Amish families near Shreve Township still collect their drinking water from the air, exactly as they did generations ago. Their systems remain operational. Their monthly water bills remain exactly what they have been since 1931. Zero. And perhaps the most unsettling part of this entire story is not that the technology exists. It is that the knowledge survived quietly for nearly a century, while industrial water systems expanded around it. The moment a permanent, low-cost solution becomes less profitable than a system requiring endless extraction, endless billing, endless replacement, and endless dependency, that is usually the moment society stops hearing about it.